So 2.6 is on on factoring quadratics. So ax squared plus bx plus c. In 2.5, a was always 1, but now a can be something other than 1. So that's what we're going to learn in this section. We're going to try to do that, and we're also going to try to apply that to a real life problem. So as we factor, the very first step you always do is, can you take out a greatest common factor? So before, a was always 1, we couldn't take anything out. But now our first step is always, can you take out a GCF, or greatest common factor? And so notice that it tells you, it gives you a little hint. We're looking at the 3 terms, what goes into all 3 of those evenly, and it's 5. And so that's our greatest common factor. And so we're going to divide 5 out of everything. So when you divide that 5 out of everything, so I'm going to take a 5 out of all my values. But when I do that, I need to write down, I need to keep track of it. So I'm going to write it down as the number that I divided by. And then I divide. 5 divided by 5 is 1, so we're left with x squared. 15 divided by 5 is 3, and we've got 3x. And then 10 divided by 5 is 2. So that's our new polynomial. And then from there, now we go back to what we did in 2.5, which is we multiply a times c, so first number times last number, which in this case happens to be 2. We list our factors of 2, which are 1 and 2, and we're looking for the pair that adds to give me 3 in the middle. So 1 plus 2 are the only factors of 2, and they add to give me 3 in the middle, so I'm good. And then we do the box. And I like the box method. I feel like it's the most straightforward. So we're going to take the first term and we put it in the first box, which in this case is 1x squared. So we take first term, put it in the first box. We take last term, put it in the last box, which is 2. The pair that we picked right here, that's what goes into the other 2 boxes. Remember to put the variable in. So this is going to be a 1x and a 2x. Once we have that, we look for the greatest common factor of each row, or what's the biggest term or monomial that they both have in common. So as I look at x squared and x, the thing that they have in common is 1x. If I look at 2x and 2, the thing that they have in common is a 2. When I look at x squared and 2x, the thing that they both have in common is 1x. And when I look at 1x and 2, the thing that they have in common is a factor of 1. So when I say they have in common, it's a number that divides evenly into the other 2, or a letter. So 2 divides evenly into both of them, so I take the 2 out. And x divides evenly into both of them, I take an x out. And x divides evenly into both of them, I take an x out. 1 divides evenly into both of them, I take a 1 out. So then when I write my answer, the 5, the greatest common factor of 5, has to be written down. And then you write down what's on the top, which is x plus 1, and what's on the side, which is x plus 2. And that's my solution. Be really careful to not forget that greatest common factor. That tends to be our biggest mistake, is when I take out a greatest common factor and I'm just factoring, that's still part of my solution. When you look at example 2, they're showing you a little bit of a different way in the book. I don't really like this. I'm just going to show you my way. If you want to go through the book and try to figure it out, that's fine. This is more like a guess and check way. I don't really like that because we have another method. So the first method, again, or my method, I would like to do is always check to see if there's the greatest common factor. So is there a number that goes into 4, 13, and 3? And because there's not, I'm going to multiply first times last. So 4 times 3 is 12. My factors of 12 are 1 and 12, 2 and 6, or 3 and 4. And what I'm looking for is I'm looking for the pair that adds to give me 13 in the middle. So 1 plus 12 is 13, so it's our very first one. And so once I know what my pair is, that's the pair that I want to pick, then I'm going to use a box to factor. So I draw my box, and the first term, that 4x squared, so this 4x squared is going to go in the first box. And the last term, which is a positive 3, goes in the last box. And then the pair that we picked was 1 and 12, so we've got 1x and we have 12x. And then I take out the greatest common factor. So I look for a number or letter that divides evenly into 4x squared and x, which will be x. I look for a number and or letter that will divide into 12x and 3. 3 is your smallest number, so it can't be any bigger than that. So does 3 go into 12 evenly? It does, so we write it down. And then we look the other way in the column. So we look at 4 and 12. 4 is your smaller number. Does it divide into 12 evenly? It does. So we write it down, and then we look to see if they have a letter in common, and they each have one x in common. We look at 1x and 3. The smallest number is 1. Does 1 go into 3 evenly? It does. And we don't have a letter in both, so we're done. So when I go to write my answer, that's how they're getting x plus 3 and 4x plus 1. And that's why I think that's a lot more straightforward than trying to do this box and having to multiply it out 3 times to find the one that works. If I look at B, same idea. Do I have a greatest common factor? Is there a number that goes into 3, 7, and 2 evenly besides 1? There's not. So I go 3 times 2, which is 6. Factors of 6 are 1 and 6, or 2 and 3. And I'm looking for a pair that's going to add or subtract to give me 7. So 1 and 6 gives me 7, but I need it to be a negative 7. The only way to get a negative 7 is if both of those are negative. So once I've found it, I want to double check. Negative 1 plus negative 6 checks out to give me negative 7. Negative 1 times negative 6 multiplies to give me a positive 6. So I always want to double check that. Once you have it, you're going to draw your box. Again, first term goes in the first box. So this 3x squared is going to go in the first box. And the positive 2 is going to go in the last box. And the pair that we pick goes in the other 2 boxes. So we've got a negative 1x and a negative 6x. It doesn't matter which box it goes into. You just need to put it there. Whoops. Okay, so then we're going to look at our row. What's a number that goes into 3 and negative 1? Well, negative 1's your smallest. Does negative 1 divide into 3 evenly? It does. I don't take the sign. I just take the number. So it's a 1. And they both have an x. And the reason why I don't put a negative there is because this is a positive. And then I look at the next one. So 2 is my smaller number. Does 2 go into negative 6? It does. So we write it down. And then because the first number is a negative, my number that I pull out is a negative. Again, if you don't catch that, like let's pretend we don't catch that right away, we will catch it when we do our double check. So 3x and 6x squared. 3 is your smaller number. Does 3 go into 6 evenly? It does. So we write it down. And then they both have an x, so we take an x out. Again, negative 1 and 2. 1's your smaller number. Does it divide into 2 evenly? It does. Because this is a negative, we take out a negative. And when we do our double check, we go x times 3x is 3x squared. That checks out. X times negative 1 is negative 1x. That checks out. 2 times 3 is not negative 6, and that helps us see that we should have had a negative there. And now negative 2 times negative 1 is positive 2. So then that checks out. And so we've got our factors right here as x minus 2 and 3x minus 1. All right, we will stop that for right now, and we'll go to the next page in just a minute.